Hello and welcome. Today, we're diving into the blueprint for the modern mechanical engineer. This field is changing faster than ever, and we're going to break down what it really takes to be at the top of your game. So, when you hear mechanical engineer, what's the first thing that pops into your head? Probably engines, maybe some gears, a lot of heavy machinery, right? And yeah, that's still part of the picture, but the reality today, in the 21st century, it's way more complex, and honestly, a lot more exciting. So the real question is, what separates a good engineer from a truly great one now? You see, the core mission is still the same. It's all about turning a cool idea into something real you can hold. But how they do that has been totally revolutionized. So in this explainer, we're going to build that modern engineer from the ground up, piece by piece, using a four-part blueprint. Okay, first up, the foundation. Before we even get to the cool software or the fancy technical skills, we have to talk about the mindset. These are the fundamental human skills that form the absolute bedrock of superior performance. Here are 5 big ones, identified by the LA Cities model as absolutely essential. It's not just about what you know, it's about how you think, how you manage a project, how you work with other people, and how you keep safety at the forefront of everything. These are the skills that take an engineer's work from, yep, that's good enough, to, wow, that's brilliant. Let's just zoom in on one of these for a second. Analytical ability. So what does superior really mean here? It's not just about getting the right answer. A top-tier engineer pulls in tons of data. They develop and weigh multiple different options, and then they can make a compelling case for why their final conclusion is the best one. It's a much deeper, more rigorous way of solving problems. All right, with that strong foundation in place, the next layer of our blueprint is a philosophy. It's about learning to think not just like a designer, but also like the person who actually has to build the thing you designed. And this brings us to 2 really important concepts, DFM and DFA. Design for manufacturing is all about making each individual part easier and cheaper to make. Think simpler shapes, maybe less strict tolerances. Design for assembly, on the other hand, zooms out to the bigger picture. It's about reducing the total number of parts and making sure they all fit together smoothly, like a perfect little puzzle. The modern way to do it is to smash them both together into what we call DFMA. And this is where the magic really happens. It's when design and manufacturing folks work together from day one. The goal isn't just a great design on paper. It's a great design that can be built efficiently, reliably, and at the lowest possible cost. So what does this look like in the real world? Well, here's a perfect, simple example. A core rule in DFMA is to try and avoid designing separate left-hand and right-hand parts. If you can just make one symmetrical part that works on both sides of a product, bam, you've just cut your design time, your paperwork, and your manufacturing complexity in half. It's such a simple idea, but it has a massive impact. Okay, we've got the mindset and the philosophy down. Now, the modern engineer needs the right tools. Our third pillar is all about the powerful digital simulation software that lets engineers test, break, and perfect their designs entirely in a virtual world, long before a single piece of metal ever gets cut. First on the list is finite element analysis, or FEA. At its heart, FEA is all about structural integrity. Say you're designing a bridge, or a phone case, or an engine bracket. FEA is the tool you use to ask, will this thing bend? Will it break? Can it handle the heat? It's all about analyzing solid objects. Then, on the flip side, you have computational fluid dynamics, or CFD. This is all about movement and flow. If your design involves air, water, or any other kind of liquid or gas, we're talking aerodynamics of a car or how coolant flows through an engine, CFD is your go-to. It answers questions about things like velocity, pressure, and temperature inside fluids. And here's a great little side-by-side. It really boils down to this. FEA is for solids and structures, and it gives you answers about stress and strain. CFD is for fluids, and it gives you answers about velocity and pressure. A great engineer knows exactly which question they're trying to answer, so they can pick the right tool for the job. So, for our final pillar, we're looking to the horizon. This is the one that's totally reshaping the entire field, artificial intelligence. And believe me, this isn't science fiction anymore. It's happening right now, and it's completely changing what's possible in engineering. So, the big question on everyone's mind, is AI going to replace engineers? Well, the consensus from our sources is a pretty clear no. It's much better to think of AI as a powerful collaborator. It's a tool that enhances an engineer's own skills, taking care of the tedious stuff, so they can focus on creativity and solving the really tough problems. So how exactly is AI helping out?
Well, it's automating all that repetitive grunt work for one. It can run thousands of simulations in the time it takes a human to run just one. And it's optimizing designs for things like weight and strength in ways that are often totally counterintuitive, but absolutely brilliant.
One of the absolute coolest applications of this is something called generative design. Basically, an engineer sets the rules and goals, like, I need a bracket that can hold this much weight, has to be under this weight, and I'm going to 3D print it. Then the AI explores thousands, sometimes millions, of possible designs to find the best one. You end up with these crazy, organic-looking shapes that are incredibly strong and super lightweight.
All right, we've looked at the foundation, the process, the tools, and the future. So let's pull it all together. What does that final blueprint for a successful, modern mechanical engineer actually look like?
Here it is. The complete picture is a pro who combines that foundational mindset of analysis and teamwork with a really practical philosophy of DFMA. They're a master of their digital toolkit, and they see AI not as a threat, but as an absolutely essential partner for innovation. This right here is the blueprint for success. You know, for centuries, engineering has been limited by the human imagination and our ability to calculate everything by hand. But now, with AI as a true creative partner, the possibilities are almost endless. So the only real question left is, what are they going to build next?